So for this example question, this time they gave us a pH value, and they're asking us to find the concentration of sodium sulfite. So first, if we take a look at sodium sulfite, it'll dissociate to form 2 sodium ions and sulfite. So this is our weak base, and it reacts with water to steal a hydrogen, which produces hydrogen sulfite as the conjugate acid and hydroxide ions. So first of all, if I'm dealing with a base, I'm working with the concentration of hydroxide, so we have to find the pOH here because the pH is not going to give us the hydroxide concentration. So 14 minus 9.75 gives us a pOH of 4.25. So 10 to the negative 4.25 will give us what that hydroxide concentration is at equilibrium. And we get 5.62 times 10 to the minus 5. We know that our conjugate acid is always equivalent to the hydroxide, so we can sub that in. If these start at 0, then the change is positive 5.62 times 10 to the minus 5 for both. And this is a really tiny number, so if we have our initial concentration minus 5.62 times 10 to the minus 5, it's such a small change that we can ignore that. So this time our unknown, or the thing that we're looking for, is the initial concentration of the weak base. And we can omit water from the ice table. So I'm looking for what's that concentration at initially, which will be equivalent to the equilibrium because that change is so small. So this time we're setting it up to solve for the concentration of the weak base. So first we have to figure out what our Kb value is, and we can do that by looking up Ka of the conjugate acid. So we're finding the sulfite ion in our data books, and the sulfite ion is right here. So the conjugate acid, HSO3, has a Ka value of 6.3 times 10 to the minus 8. So that's what we're going to substitute in to solve for Kb. So we get a Kb value of 1.59 times 10 to the minus 7. So this is what we'll sub into our equilibrium expression. So we have hydroxide squared divided by concentration of the weak base. So if I rearrange this to solve for the concentration of the weak base, we get the concentration of hydroxide, which is 5.62 times 10 to the minus 5 squared divided by Kb, which is 1.59 times 10 to the minus 7. So our concentration is equal to 0.0199. So this is the initial concentration of the sodium sulfite. Just double check though that this is a 1-to-1 ratio because technically it asked us for the concentration of the sodium sulfite, not the sulfite ion itself. So it is a 1-to-1 ratio, so we can assume that those are equivalent. So 0.0199.